Welcome back. Today we're diving deep into Chapter 10, which covers Hydronic Radiant Panel Heating. This is one of the fastest growing sectors in the heating market, and for good reason. We're going to explore how it works, why it feels so good, and the nitty-gritty of how to design these systems.
So first things first, what actually is radiant heating? It's fundamentally different from the forced air or baseboard heating you might be used to. Instead of heating the air, radiant panels transfer energy directly to objects in the room, including you, through thermal radiation. Think of it like the warmth of the sun on a cold day.
Technically speaking, a hydronic radiant panel is any object we warm up by circulating heated water through it. To qualify, it needs to release at least 50% of its heat as radiation. While we mostly see this in floors, about 90% of the time, you can actually put these panels in walls and ceilings too.
This isn't exactly new technology. The Romans did a version of this, and in the 1930s and 40s, we used iron and copper pipes in concrete. But the real game changer happened in the 1980s with the introduction of PEX tubing. That flexible polymer tubing sparked a massive resurgence because it made installation so much easier and more reliable.
Why do people love this stuff? Well, the comfort is unmatched, which we'll get to in a second, but it's also invisible. No ugly radiators. It's silent, it doesn't blow dust and allergens around the house, and because water is such a good transporter of energy, it can be incredibly efficient, often saving 15 to 50% on fuel compared to forced air.
Here's the cool part about the physiology of comfort. Our bodies want our feet to be warm and our heads to be slightly cooler. Forced air systems do the opposite. They push hot air to the ceiling, leaving your feet cold. Radiant floors give you that ideal heating curve, keeping the heat exactly where your body wants it.
Let's look at how we build these. The most economical method is slab-on-grade. We embed the tubing directly into the concrete foundation. The concrete acts as a massive thermal wick, spreading the heat out laterally and then radiating it up into the room. Now, where do you put the tube? Some people just throw it at the bottom, but that's not great. If the tube is too deep, you need hotter water to get the heat to the surface, and the system responds really slowly. Ideally, you want that tubing right in the middle of the slab for the best performance. Spacing matters too. The closer the tubes are, the more heat you get, and the lower your water temperature can be, which is great for efficiency. But more tube means more cost and labor. For residential floors where you might be walking barefoot, we usually stick to 12-inch spacing or less to avoid hot and cold stripes on the floor. Installation is a process. You start with a vapor barrier and insulation. Don't skip the insulation. Then you tie the tubing to wire mesh. And here's a pro tip. Always pressure test the tubing with air before and during the concrete pour. You do not want to find a leak after the concrete sets. What if you aren't pouring a new foundation? You can use a thin slab system. This is where we staple tubing to a wood subfloor and pour a thin layer, maybe 1.5 inches, of concrete or gypsum underlayment over it. It adds weight to the floor, which you need to account for structurally, but it works great for second stories. If you can't pour concrete at all, we use tube and plate systems. We use aluminum plates to grab the heat from the tube and conduct it sideways. You can install these on top of the subfloor using sleepers, or staple them underneath the floor joists. It's a dry installation, which is a huge plus for retrofits. And don't forget walls and ceilings. A radiant wall has very low thermal mass, so it heats up fast. And ceilings? They're surprisingly effective. They shine heat down like a light fixture. Plus, unlike a floor, nobody's going to put a thick rug or a couch over your ceiling panel and block the heat. When you're laying out the tubing circuits, you can't just wiggle them around randomly. Rule number 1, route the supply pipe, the hottest water, along the exterior walls first. That's where the heat loss is greatest, so you want to attack that cold edge immediately. You also have to watch your lengths. If a circuit is too long, the water gets too cold by the end and the pump has to work too hard. For standard half-inch tubing, you generally want to keep circuits under 300 feet. If a room needs more than that, you split it into 2 parallel circuits. Here is a critical design factor: floor coverings. Ceramic tile is great. It conducts heat right through, but a thick wool carpet? It's basically an insulator. It traps the heat in the floor. If your client wants thick carpet, you're going to need much hotter water to push that heat through, or radiant might not be the right choice. All these circuits connect back to a manifold station. This is the heart of the system. It's where you balance the flow so every loop gets the right amount of water. You can even put electric actuators on these valves to control different rooms as separate zones.
To wrap up, hydronic radiant panels offer unsurpassed comfort and efficiency, but they aren't plug and play. They require careful design, considering heat loads, tube spacing, and floor coverings. But when you get it right, there is honestly no better way to heat a building.